Hey everyone, and thanks for listening to the Metis Tech Show. Today we're going to talk a little bit about psychometrics and the psychometric chart, but first, the Metis Minute.
Today's Metis Minute is on sensible and latent heat. Sensible heat is the energy that changes the temperature of the air. It's what your thermostat actually measures. For example, if you turn on your AC and the room drops from 78 to 72 degrees Fahrenheit, that is sensible cooling. Latent heat, on the other hand, is the energy used to change the moisture content of the air without changing its temperature. That's the work the system does when the coil surface drops below dew point and water condenses. A great example is a muggy summer day. The system may hold 72 degrees Fahrenheit, but if it's pulling gallons of water out of the air, that's latent cooling at work. Together, sensible and latent loads make up the total cooling capacity of an air conditioner. Get the balance wrong, say too much sensible and not enough latent, and the house may feel cool but sticky. Thanks for listening to today's Metis Minute. Now let's start the show.
The Metis Tech Show. Welcome to the Metis Tech Show, a show for HVAC professionals by HVAC professionals.
I like how you guys bounce back and forth between heat pump talk and food talk.
The Metis Tech Show.
Mitsubishi.
All right, so last week, I think we're all on the road, but Steve, you were different. You were in Atlanta, Bryn and I were in Dallas. Juan was with us in Dallas. Who
Yeah, I
else was
missed you guys.
Who else was in Dallas with us?
We were there with the whole service team.
Oh, yeah, that's right.
So-
I forgot about that. Yeah.
A lot of
There was
people
like 60 people, 50 or 60 people there. But we got there, we landed, and we went to lunch. Twisted Root
Yeah.
Burger. I think you DoorDashed it last time you were there. And
Yeah.
I got to tell you, I'm looking at their menu. And, right off the bat, the first thing is the Western, which is pepper jack, crispy bacon, fried onion strings, pickled jalapenos, lettuce, and tomato. All right, I'm good. And then the next one was a tree hugger, and I read plant-based, and I went on to the next one. I ended up getting the All-American, which was basically just American cheese and bacon. But there was one that jumped out at me. It's called the Turklucken. And it was grilled turkey patty, 2 chicken tenders tossed in hot honey butter, topped with cheddar cheese, fried eggs, crispy onion strings. I would have gotten that if it wasn't a turkey patty. If it was a beef patty, I would have been all over that. That looked wicked good. It looks wicked good now.
Yeah, I had the steak me home tonight.
Yeah, that's a beef patty, shaved roast beef, American and provolone cheese, grilled onions, and beer sauce.
Yeah, I had bacon jam and fried egg on that. I think those are just additions, toppings, whatever you want to call it.
Yeah, and then the other thing they had, I thought that side, they got a bunch of sides, but then they got a thing called the test ride, and Bryn got this, and I think I ate half of it.
I got the Westerner.
No, the test ride, what you got.
I got the Westerner.
No, I'm talking about for the sides.
Oh, that appetizer.
Yeah.
Yeah, okay.
So
I forgot what it was called.
Yeah, it's a sampler plate of our hand-punched French fries, onion strings, Quincy's fried pickles, fried green beans, which were surprisingly very good, and fried carrots are very good too, house-made chips with a side of chipotle ranch and peppercorn ranch. And a lot of places that have homemade chips or house-made chips, they just, But these were actually really good. It's the first time I've had homemade or house-made chips that were actually excellent.
Yeah. Yeah, I went to,
McDonald's?
yeah. No. I actually had a great steak at Jack's Meat House. So I wasn't like super excited to go to the Jack's Meat House, and they're good. I think we just wore them out. But someone had the idea to go there. They had reservations, and sales was paying. So
Oh, yeah, no. I'll go to Jack's Meat House if somebody else is paying.
yeah, so definitely Jack's Meat House, and we got the bacon appetizer was just. I think we might have talked about this before. That there's strips of thick cut bacon.
Yeah, and I think they're cured, and they come on this stand, and then they have this maple syrup you can dip it in, or homemade peanut butter.
Yes.
And if you've never had peanut butter and bacon, you have to
It's like
give
a
it
peanut
try.
butter sauce.
Yeah,
So.
but try a peanut butter and bacon sandwich one time. It's wicked good.
Yeah. Yeah. Have you ever had peanut butter on a burger?
Yes, Jack's Meat House has that one where
Okay.
I forget what else it comes with it, but it's peanut butter. When I first read the description and it had peanut butter on it and something else, I forget what it was. I'm thinking, it sounds interesting. I wasn't sure, but it was so good. It's this homemade peanut butter, and it just goes good with the beef. It goes good with bacon. I love peanut butter and bacon sandwiches. I don't have them very often, but it has to be good peanut butter. I mean, they're homemade peanut butters. It's not like it's not going to go. You're not going to go to a grocery store and get a can of Skippy. I mean, it's way better than that. It's way better than natural peanut butter. I mean, I don't know what they do to it, but it was delicious.
Yeah, so I had a ribeye that was really good. And Bryn, you're gonna like this. I got shredded Brussels sprouts.
Really?
Yeah, so I got the Brussels sprout side because it had that honey and chili, almost like the Longhorn recipe.
Yep.
But I was shocked when I came to the table. I'm like, what is this? This isn't Brussels sprouts, and they were shredded. So they ran them through some kind of shredder, and
Were they still nice and crispy?
Yes.
Yeah,
It
that's
was
awesome.
nice and crispy and really good. And Paul would
I
have
got nothing to say about Brussels sprouts. It's a vile weed. They're disgusting. No, I've had them wrapped in bacon. They still suck. I'm sorry. Can I say that?
Yeah.
They're not bad.
Yeah.
They're awful. No one should have them.
I actually thought you were going to mention something about there being onions.
Oh,
involved.
no. That's a winter recipe. That's coming soon.
Winter
Heading into
states.
fall.
Yeah.
Yeah, the onions. We'll be busting out onions. But right now I'm on a corn on the cob because it's local in my area. They're harvesting all the
time of
corn,
year.
and you get all that beautiful sweet corn. So finishing off the summer with grilled corn.
Yeah. It's good stuff.
I love grilled corn. Best way to do it. And this time of year is a good. It's a local stuff. It's all ready now.
Yeah. It's great. So welcome, everybody, to the Metis Tech Show. What are we talking about today?
Well, you wanted to talk about psychometrics.
Crazy.
Yes. I thought it'd be interesting.
So, full disclosure, at one point in my life, I used to teach this. I used to know a lot more about it than I do now. You know, and I think we mentioned this a few episodes, or at least I did. But the thing that amazes me about the psychometric chart is the foundation for it was developed by Willis Carrier in 1911. No computers, no calculators. The slide rule and paper and pencil was probably all he had, and it's been changed and added to since then. But he came up with it, and it's something that every HVAC engineer will use, and not so much a technician may not need it, but you kind of need to understand how they all go together.
Yeah.
You need to know. You need to have a general knowledge of the humidity, the dry bulb, and the wet bulb, and how they all tie in together. Because you don't remove humidity, that's a problem. Too much, not enough. So you got to know these things.
Yeah. Yeah. So actually, the reason why I thought or came up with the idea of talking about this was last week we were talking about the psychometric chart, and when it came to swamp coolers. Mm-hmm. So we're talking about how swamp coolers work in certain areas, but not others, and why that is. So I thought it'd be cool to get involved with that and see what's actually going on there.
And a swamp cooler, very basically, is just water flowing and air flowing over the water. Right. So if I have water, and if I have water draining down a coil, and I blow air across that, I'm going to cool down the air. If I have a humid area, like if I do this in Louisiana, the panhandle of Florida, Mississippi, it's not going to work. But if I go to Arizona and do this, it's very dry. It's probably going to work. In fact, I think I told you, my brother used to live in Phoenix. And the first time I went out there, you walk outside and it's like 110 degrees. And he used to say, "Oh, it's a dry heat." I said, "All right, let's turn the oven to 110 and put a potato in there. It's going to bake. It's going to cook." But he had this PVC pipe, the perimeter of his patio.
Yep.
And it had these little nozzles on there, and cold water went through it, and it would create this mist. And when you have a mist and water evaporates, and anytime something evaporates, it takes heat with it. So you'd be out there, it'd be 120 degrees, and these mists, this mist, fine mist, would go out there, and it would cool off the air around you. And the mist hits you, it would never hit you, because by the time it got to where you're sitting, this was only about 6 feet off where we're sitting.
Yeah.
It would be dry. It would evaporate and made it bearable out there. We could not do that in New England with the summers we have here. It's too humid, and now you'd be outside hot and clammy and wet, and nothing's worse than that.
So yeah, when it comes to psychometrics in general, I thought that was kind of an interesting concept. But just let's get some definitions out of the way. So first would just be some of the key properties of psychometrics, things like dry bulb, wet bulb, dew point, relative humidity, that kind of stuff. So dew point, just basic description or definition, is temperature where air becomes saturated and condensation begins. Wet bulb, right, is representing the cooling effect of evaporation. Obviously, dry bulb is our sensible temperature, right? So it's just the actual temperature reading on a thermometer. And so these three things kind of play a role in what we do and what we design and how we design and size equipment, because depending on the application, you may want to have something that is better at removing latent heat or something that is more geared towards comfort cooling, where we're focusing more on sensible heat. And then in some cases, in most comfort cooling, it's both, right? We care about both. We want both of those.
In a lot of areas, yes, unless you're in a desert. And if you're in a more humid climate, you're more interested in more latent heat, not so much sensible. If you're in a drier climate, then the sensible is what's important to you. Where we are and where a lot of the country, if you've got any humidity at all, you need to get rid of both.
Right.
You need to remove both. In dew point, I put a glass of ice water here, and it's fall now. The leaves are starting to change. We're in middle September. If this was a month ago or 2 months ago and it was humid, we didn't have air conditioning on, this cup would be soaking wet.
Yeah.
Just because there'd be a lot more moisture in the air. So I don't know what the dew point is. I don't even know what the dry bulb is in this room here. But if I had a psychometric chart and I know any two of these things, and there's a lot of them, there's relative humidity, there's grains of moisture per pound of air, and I forget, cubic foot of air. There's all kinds of things you can get. But if I know any two, I can get anything else. But the dew point here, there's just a little bit of moisture on this glass. It's not so bad. So this glass must be at the dew point.
Yeah, I mean, basically, the only way we're getting condensation on the outside of that glass would be that the surface of that glass has to be below the dew point. So the actual surface temperature of that glass would have to be below the dew point for this room. And so now you'd go, okay, well, how am I supposed to know what that dew point is, right? How do I know what the dew point is? Because otherwise, how am I going to know if I'm going to condense? So there's actually a formula, and there's a really formal, specific formula, but there's also like a quick little easy one to do. And essentially what you do is you take the wet bulb temperature, which you can measure with either a sling psychrometer or now they have probes that measure both the dry and wet bulb for the space. Yep. Yeah, right. So you take that wet bulb temperature, and from that you subtract the dry bulb minus the wet bulb divided by 3. So keeping the math simple, if it's 70 degrees dry bulb, 61 degrees wet bulb, you have a temperature difference there of 9 degrees. Over 3 gives you a result of 3, and you're subtracting that from that 61 degree wet bulb. So in that case, your dew point is about 57 or 58 degrees. So you can use that point to go, okay, 58 degrees is my dew point, and what are our coils typically? Between 40 and 45 degrees, right? And so we know that with our coil being 40 to 45 degrees and a dew point of 57 or 58, we are going to condense. There's going to be condensation on that coil, which is good. That means we're removing humidity from the space.
Right.
Yeah, and if you're in an area like Sergio's our instructor in Los Angeles, he doesn't get a whole lot of dew point. They don't reach a dew point a lot out there. And I like this story because I thought I was telling my wife this weekend. When I go out into the car in the morning, it's covered in dew. It's covered in condensation. I have a sunroof. I know not to open it. Yeah. Sergio was here and he was visiting Boston. He had a car with a sunroof, and he said, "Oh, it's nice. I'll open the sunroof." First stop sign he comes to, all that water just came pouring in on top of him. It doesn't happen. It doesn't happen where he is. It's nice and dry where he is, so that doesn't happen. So it's important to know where you are and when you can open the sunroof. Right? Just saying.
Yeah. Yeah, we deal with that kind of stuff all the time. All summer long, it's condensation. Everything condensates. Every glass you have, you get a cup from McDonald's or coffee cup from Dunkin' Donuts or Starbucks, it's going to have condensation on the outside of it because that cold cup compared to the relatively high dew point that we have during these humid summers, it's gonna condense
And this is one of the
or
reasons.
condensate.
Yeah, one of the reasons why we have to insulate the ductwork when it's in an unconditioned space, why we have to insulate the line, the suction line, in our case, both lines, and why, in a lot of cases, we have to insulate the drain lines. Again, first time I taught a class in California, I was talking about insulating the drains, and they said, why? You go, well, don't your drains sweat? They go, no. That's right. I was actually in the desert. Of course it doesn't sweat. But here it does. If I run a drain across an attic or in a basement, and it's going to sweat because it's definitely going to hit the dew point.
Right. Yeah. So they have the basic psychometric chart, and that's kind of what people use or go off of to kind of determine where we're at. But essentially, across the x-axis of that psychometric chart is just your dry bulb temperature. And then the y-axis is a measurement of how much humidity is in the space. And so most curves, when it comes to cooling capacity, are in kind of a linear form, where as we drive down temperature with an indoor coil, right, we're going to drive down temperature, we're also going to remove humidity. So we're going to see kind of a linear curve down towards as we go to a lower temperature. Now, there's other equipment, like, say, we have critical cooling, like the SMEXT, where we're kind of doing both. But what does our system do? Like, what are we supposed to do if we bring that temperature down to where we want to be, but now our humidity is too low? We start to dry out the space. That's where electric reheat comes in, or some kind of reheat comes in.
Right.
And that's how we control those more critical situations, is we say, let's get that temperature, or that humidity and temperature down. And then if we overshoot our set point, we'll just reheat the air, because the humidity and temperature are both critically important.
Right.
A little bit different with comfort cooling, but with process cooling, you need to be specific about both measurements. And so we use the coil to either bring down temperature or bring down humidity, or do both just in the process of cooling, and then use a reheat to basically move to the right across that x-axis, where we're staying at the same humidity, we're just increasing dry bulb temperature.
Right, and a lot of times I want to remove just the humidity and not necessarily lower the temperature. And that's how a dehumidifier works, similar to what you just said. It's got the cold coil and then the hot coil. It puts an evaporator and the condenser right in the same airflow path of air.
And that's a data room unit, basically.
Yeah.
So that's the Liebherr. That's our SMEX precision cooling. And we say precision cooling, that's doing it within a degree.
Yeah.
It's quite impressive.
Yeah, and that's all thanks to having an electric reheat. So we, as soon as we start to get beyond that cooling set point, rather than with our comfort cooling, it's also a heat pump. So when we need to bring the temperature back up, we have a hysteresis, right? A couple degrees on either side, where we'll let it overcool a little bit before we actually switch over to heating. And that's to maintain efficiency. And because most of the time people aren't going to notice a 2 to 3 degree swing. In process cooling, we don't have that option. It has to be a specific temperature. So as soon as we draw low, we'll keep that unit in cooling. We'll shut it down or start to slow it down, and then just use electric reheat, so they can run at the same time. And part of that is to be able to still draw humidity out of that space without dropping temp too far. We can use that electric reheat at the same time as the cooling. So wet bulb temperature, we talked about, it's just represents the cooling effect of evaporation. But we historically, they did it with a sling psychrometer, where it was actually like a wick or a piece of cloth over a temperature sensor, and then it was passed through the airflow. And what they discovered, this Carrier gentleman, right, he discovered that by doing that, it's for some reason dropping the temperature on that temperature sensor. So why, just by wrapping it in that wet cloth, do we now all of a sudden see this drop in temperature? It's because we're able to see what the evaporative properties of the moisture in the air, and what actually is happening with that airflow.
And anytime something evaporates, it takes heat with it.
Right.
So, and I had one in my truck, a sling psychrometer, and you have to wet the little wick on the end. You have to swing it around like you're a crazy person. People are looking at you. Now they have digital tools. You don't need that. They have the psychometric chart all on. They just do it for you electronically.
Yeah.
You can get a program where you type in any two, and it gives you all the rest. It's more stuff than the guy in the truck would ever need to know. But if you're an engineer out there, you definitely know more about this than I do, because I've been talking most of it.
See, the nice thing about knowing even the basics, though, is I'm sure you've been on the service call, or some folks listening have been on the service call where the unit is not performing the way the homeowner wants, right? Something is not performing the way we want. They either feel uncomfortable or they think it's not performing well. And what do we usually do? The first thing we're going to do is just take a delta T. And we could have a proper delta T, but if our airflow is not dialed in, we may not be removing enough moisture. Well, now we have a calculation that's just quick to see, what's our coil temp compared to what my dew point is. And usually that leaving air temperature to the saturation of that coil, it's called an approach temperature. You want it to be about an 8 to 12 degree difference. So you measure your supply air and you compare that to the saturation temp, which we can use TH2 on our equipment because it's right after the LEV. So we assume that to be a saturation temperature. So we can take that TH2 reading, compare it against the leaving air temperature, and we should have about an 8 to 12, typically 8 to 12 degrees for cooling. So by using some of these formulas, we can diagnose, like, is my airflow too high, right? Or is it a ductwork issue? Is it charge issue, right? What is the reason for my coil either being way too cold or way too warm? And at that point, determining, is my airflow adequate? Is it too high and too low? So the interesting thing about wet bulb, and we talked about this before we started recording, is wet bulb will always be lower than dry bulb, except when you get to 100% relative humidity. At 100% relative humidity, dry bulb is wet bulb.
Yep. And then you probably have fog.
Yeah.
It's misty in there.
Yeah, it's a little foggy, like a pea soup fog. My old boss used to say when you get to that point, pea soup fog.
Yep. So now it comes down to airflow. That was another one I want to talk about because airflow obviously plays a huge role in those dry bulb and wet bulb temperatures, and making sure that your airflow is adequate is critical to making sure that your equipment's going to work the way you want it to. And so what I was curious about when I started doing the research for this podcast is, what is the effect on on wet bulb, depending on the airflow? So if we have not enough airflow, what happens to my wet bulb? If I have too much airflow, what happens to my wet bulb? Because we use that calculation in dew point, and we talk all the time about, if your fan speed's not set right, you may not bring down sensible or you may not bring down latent. So how do they all relate? You know what I mean? What are the actual numbers and what happens?
Yeah, well, when they first came out with ECM motors, that was the attractive thing behind an ECM motor. It was variable speed, but what it would do, and the one I had in my house until recently, is it would take 10 minutes to get up to full speed in cooling mode, in air conditioning mode. And that coil, that fan would start off with the first, I forget what it was, 2 minutes, 3 minutes. It would be at half speed. So that air is flowing across that coil much slower. That coil's getting nice and cold, and it's removing a lot more latent heat or a lot more humidity at that point. Then it would slowly ramp up. So the first 10 minutes or whatever it was, 10, 15 minutes, I can't remember what it was, that system ran, it would remove a lot of the humidity at that point. And then it evens out, and in the variable speed, how they were, if they would react to a restriction. So if your filter got dirty and you notice you can now hear your fan and you couldn't before, it's an airflow restriction. So check the filter. Maybe somebody closed too many registers. I remember putting these in these old homes. There were 150-year-old homes, and the ductwork was put in the 50s, right? And you put this in there, and it would sense all those restrictions. You turn it on. And I had this one house in particular. I remember because I knew the family they were friends with my parents, and put a filter in there and turned it on, and it had 50 years worth of dirt in that ductwork that had sucked right in and plugged that filter within the first hour. It was just plugged. I said, holy cow. So, and I had like a 5-inch filter in there. So, well, let me just do a couple of 1-inch filters in here or 2-inch filters until we get this done. But and then we had airflow. And I don't know how many times we can say it's the airflow. Fix the airflow before you do anything else.
Yeah, my favorite thing is the ABC, airflow before charge.
Yeah.
If you start to suspect a charge issue, just verify airflow.
Yeah.
But
won't work. Won't work. If the airflow's not right, nothing you can do is going to make it work well.
Yeah. So typically lower airflow, you're going to have a colder coil, which means that you will have likely a lower wet bulb temperature, which means that you'll have more latent heat removal.
Yep.
Your wet bulb temperature will decrease. However, if it's too low, you might start frosting up the coil because now you don't have enough airflow. Coil starts to drop in temperature, continue to drop, and then eventually you could frost over. Now, high airflow, so too much airflow, the air is not in contact with the coil for long enough. So typically the coil is going to be a little bit warmer. You'll have less latent heat removal because there's not enough time for that air to be in contact with the coil. It's moving too fast. And so what happens to your wet bulb temperature is it'll actually increase. So this is exactly kind of what we were getting into when it was, we talked about the air handler, right? And balancing. We've done example after example of how to balance the airflow on an air handler. And this is part of it, right? If you have your air moving too fast, your delta T probably is not going to be great. But the biggest thing is you're going to end up not removing enough latent heat. So then even if you do drop the temperature down to where the set point is, it's uncomfortable, right? And so it was just kind of neat to go through some of these exercises and see how it relates to psychrometrics in general.
So that's going to mean checking your static on our air handlers, our PAA coil, just not just walking away, making sure your airflow set correctly and your ductwork is sized correctly.
Yeah, absolutely. And then everything's insulated.
No, something just occurred to me. So if you're out there, Steve, if you're going out to dinner with your wife and you notice that the glass is forming, a thin coat of moisture on it, if you start explaining to her the psychometric chart and telling her exactly the science behind this, she is going to be so impressed. And she's going to love you even more.
Sure.
So for you young guys out there who are dating, this is how you impress the ladies, or ladies, you tell this to a guy, you will impress him and show him how smart
If
you
you
are.
really want to impress him, bring a sling psychrometer with you on the date and start whipping that thing around.
No, I'm joking because
yeah.
because my wife gets so aggravated with me when I look at the ice cubes in a glass and I tell her they got a Hojisaki. She goes, "Why do I care?" There's a restaurant where they had 4 air handlers, horizontal air handlers above the seating, and one of them has a drain pan underneath it, and it's a plastic drain pan, and it's buckled. And it's getting ready to just drop, and it's right over this table. I go, "Never sit there." And she goes, "Why?" And I tell her, because it's going to drop someday. And it hasn't in the last few years, but, I'm still not taking a chance. But when I start looking at the ductwork, you start looking at things. You're in the HVAC business. You look at these things.
You just reminded me of something, too, because back in June, we had our instructor meeting, and we stayed at the Westin in Duluth, in Georgia. And I was on the 9th floor. So what's on the 9th floor of the Westin?
I have no idea.
The bar.
Oh, yeah, that's right.
The outdoor bar.
Yep.
So it was humid out,
Yep.
95 degrees. What did they had all their doors wide open. And we were sitting at the bar. It was me and Gary and Felix, and I think you may have come up at one point. But the bartenders could not figure out why water was dripping on the bar all the way around.
That's right.
So I don't know if you remember that.
Yep.
And why was that happening?
The dew point.
The dew point. The diffusers in the ceiling.
Yep.
And they had linear diffusers.
Yep.
And they were soaking wet. You could see the beads of water on them, and it was just pouring down. And the bartenders were like, "What is going on? What do they need to do to fix that?" Shut the doors.
Shut the doors.
I mean, it was not the type of weather you want to have the doors wide open. It was nice out, but way too humid. So
Yeah, I don't know why they open those doors when the weather's like that.
yeah, and that'll cause all kind of sheetrock damage and everything else. So
the humidity is not good.
We actually talk about that with the 4-way cassettes. Is if you end up changing directions, you don't go all 4 directions. Maybe you shut down based on the configuration of the room. You may shut down one of those vanes. Well, the problem now is that vane has been manually closed and it's got cold air rushing against it. Now, if the dew point in the room is above the temperature of that surface, you're going to start to get condensation and it starts to drip. So we actually have those insulating pads specifically for the PLA that we recommend if you're going to shut down vanes for that reason. So.
Now, obviously, we don't deal with humidity here in the Northeast like they do down in Florida, down in Georgia, down in those cold, those warm, high humidity states. So we get away with a lot of things here. Mm-hmm. Get away with oversizing.
Yes.
You get contractors that go in and it's about a 3, it's about a 3.5 ton.
The rule of
you
thumb.
can't do that, right? You're not supposed to do that, and we get away with it here. Mm-hmm. We get away with undersizing ductwork even on furnaces, and like we talked about it before, furnaces will, spend their life just tripping on high limit. It's so. You got to make sure that we're sizing the ductwork correctly, sizing the systems correctly here in the Northeast. And we get, like I said, we get away with it because we're not dealing with humidity on a constant basis like they are in Florida.
Yeah. But that being said, it's actually funny you mentioned that because I was thinking about this in the inverse, right? In the wintertime, because our winters tend to be pretty dry, you could potentially benefit from humidifying the space, because that heat, right, is going to feel,
Yeah.
you're basically going to have more heat capacity by having more humidity in that space, right? So in the inverse, instead of trying to remove humidity, adding humidity is going to heat the space better,
Right.
because both latent and sensible matter.
Now, humidity is a compromise. Okay, you can't humidify too much. If you add humidity to your home in the winter, and the condensation is now forming on the windows, then you're causing a problem. Yeah. Right? Now, listen, our bodies would be comfortable at 50%, 75% humidity if we're heating a space. That's what we would want. We'd be nice and comfortable. But it's a compromise. You're looking at about 25, 30, maybe 40% humidity. You know, it beats 10 or 15 or 20, but you can't. I mean, if my wife used to, you know, we see it until I got the new windows. If like cooking, it's wintertime, you're boiling some soup or whatever, the kitchen window would fog up.
Yep.
It happens once in a while, you're okay. But if that's a constant condition, now you've got all kinds of other things you got to worry about. And as Steve mentioned, home does not like humidity. The things in the house don't like that constant humidity. That's why you need an exhaust fan in the bathroom. Somebody takes a shower in the hot water and all that moisture, the dew point, the wall hits the dew point. I got all that moisture on there. You need that exhaust fan to get that out of there. Which, by the way, getting back to the wife, she actually ran into the house and told me there's something wrong with the house because my son was in the shower and I go outside and go, what's wrong? And there's steam coming off the roof right where the exhaust is for the bathroom vent.
Yep.
And I said, no, there's nothing wrong. She goes, that's never happened before because it happens all the time.
In the winter.
It's just the conditions are just right where you're seeing it for the first time.
Yep. Do you ever be in the car in the middle of the summer and you have the AC cranking and you can see your breath?
Yeah.
It's the same thing. Or you get on an airplane. Another great
Conditions
example.
conditions are perfect for that.
Yep. Airplane in the
Same thing
middle
when
of
I go
summer.
fishing in the morning. Get out there on the lake in the morning. There's steam rising off the lake. Right, that happened this morning.
Yep.
Water is warmer in the lake than the outside air temperature.
Yep.
My son loves it. His room is closest to the air handler. And when it's humid and they first turn on the AC, that's it. And he goes, there's fog coming out of my vent. Don't worry about it. Yeah. It'll go away in a minute.
Yep.
But I just want to go over some of the readings you can get off of this. And I just got my notes here. But it's just amazing. If I know any two of these, I can figure out the rest. And as you mentioned, the horizontal axis, that's the dry bulb. It's the dry bulb temperature, just regular. And as you move from left to right, the air temperature increases. The vertical axis is the humidity, or sometimes called specific humidity. And it's a vertical axis that's on the right. It shows the humidity ratio equal to pounds or grams of water vapor per pound or kilogram of dry air. And as you move up, there's more moisture in the air. And then you get the curved lines, which is 100% relative humidity saturation line. And the curved upper left boundary is where the air is fully saturated and the relative humidity is at 100%. And along this curve, you can get the dry bulb temperature, wet bulb temperature, and the dew point again. And then there's the relative humidity curves, and these are the curved lines that are inside the chart from 10% to 100%, and they show the relative humidity. And it's a relationship, right? And it's moving towards the saturation curve means that the air is wetter, and moving away means that the air is drier. The wet bulb temperature lines you mentioned, it's diagonally, a slightly curved line sloping downward to the left, and the wet bulb is measured with a thermometer, like we said, wrapped in a wick. And you need to know the wet bulb temperature a lot of times.
Yes.
The dew point is it's basically the temperature at which condensation will form on a surface. And then one that I don't think we'll ever need in here for what we do, but it's the enthalpy line, and it's the total content of energy. And those are diagonal lines, often parallel to the wet bulb, and they show the total heat content, latent and sensible, and it's measured in BTUs per pound of dry air.
Yes.
I mean, this is just amazing, some of the stuff they get. I love to geek out on this stuff.
Yeah.
And then you got the specific volume lines, and they tell you the volume occupied by 1 pound of dry air at that condition. So is it a cubic foot? Is it 2 cubic feet? It just, I don't even know how anybody can even think of this. This is just amazing.
Yeah.
I wonder how much space a pound of air does it take? Pound of dry air. Who cares?
Well, the thing is it's probably, if you think about it, that's how our equipment gets engineered.
Yeah.
It's based on enthalpy curves and, where we actually fall on that and how we get our cooling capacity. When we say that it's a 9,000 BTU head, we're using these calculations to make that determination based on the enthalpy, the difference in humidity versus supply and return. These are all calculations that get made for us to be able to calculate what that actual BTU hour is on that particular coil. So it's pretty interesting.
We should have had an engineer on this episode, and we could have watched our eyes glass over as we talk. Oops, I'm sorry. That's where I set off the camera.
All right. Anything else we want to add?
Did you already go over the key sound bites here? Dew point, we mentioned that. Wet bulb. I think the 3 that we're going to deal with, it's probably 4 that we're going to deal with the most as technicians. Obviously, wet bulb and dry bulb. Mm-hmm. Relative humidity and dew point. I don't think we need, as techs, we don't think we need to know the other stuff. But those are the 4 that I think it's important
I agree.
for us to know. You see condensation on a window, whether it's inside or outside. I've actually seen it where it's on the outside too, again, depending on the conditions. If it's really hot outside and you cool your house way down and it's hot and humid outside, if you can get that temperature down, I've seen the moisture form on the outside of the windows.
Yeah. I mean, I think ultimately it's just another tool in your belt as far as diagnosing airflow in systems and performance, essentially, is if you think about, at least for me, when I was doing service, most of the time I was just checking a delta T and kind of saying, okay, we're good. But if I was in a situation where that delta T was either borderline or low, or it was high, but it was satisfactory, but the customer was still upset, that's where it might hit my wall, where I'm like, I don't know what else to do. I've got a good delta T. I don't know why it's not cooling. Well, now we have some other things we can do. Well, let's check and see where we're at as far as how much latent heat are we removing? Is this an airflow issue? Do I have other problems? So just another step we can take.
All right.
Yeah.
Okay, I think that covers it for Psychrometrics. I hope we didn't bore anybody.
We probably did.
Yeah, I know, we probably did. People driving in the trees, falling asleep.
Yeah.
Hopefully you had your coffee before the episode. It's in morning time.
Yeah.
You didn't just eat a big 12-inch sub from Subway and now you're tired anyway. Just saying.
Do you have like a specific type of coffee that you like?
Yes, I like Pete's coffee.
Pete's, okay.
In fact, the best thing about going to Dallas is you go into Terminal E, and there's a Pete's coffee place right there. Yeah. They're all over California. There's a couple here in Massachusetts, but that's my favorite coffee, Major Dickinson's blend.
Okay.
I don't know who Major Dickinson is, but he made good coffee beans.
What about you? Are you specific about anything?
I don't know. I just I kind of like Starbucks Pike Place, their house blend. It's a really good coffee.
Yeah. That actually reminds me. So, where do you get that from? The Starbucks coffee, like from the actual. Like, do you go to the grocery store, or do you get it from?
Now we're starting to get actual Starbucks restaurants. In my location, around my area.
Yeah.
In the past, it was just K-Cups from the grocery store, or, it's funny. Back in the day when I worked at Rhode Island Hospital, I'd go in for second shift or third shift, and I'd bring in a bag of fresh ground Starbucks, and there was only one in Seekonk next to the hospital that I knew of.
Yeah.
And I would bring that in and brew a pot, and everybody would be wide-eyed and like, holy crap, this is good stuff.
I'm not a big fan of Starbucks. I'm not a big fan of Dunkin' Donuts either. But Starbucks, so Steve and I, it was the second time I was in inside of a Starbucks store was with Steve, maybe about, 6 months ago, 9 months ago in California. It's 5:30 in the morning and they're open, and I don't like drive-through. So we walk in and I go, look, I just want a cup of coffee, black coffee. Nothing frappe'd or chino'd or latte'd, mocha'd, just, okay, sure. And the guy says, can you give me a name for the coffee? And I'm like, you want to name the coffee? I go, call it Arthur.
Yeah.
And he goes, no, I need a name to put on the cup, your name. I go, there's two of us in the store. What do you need my name for? Pour the coffee and hand it to me. I was aggravated. I just don't like the whole
Yeah, it sounds
thing.
Got to go with the flow. Well,
Yeah. What's that movie? What's that movie? The guy says, "Congratulations, you're stupid" in 3 languages.
I don't remember the name of the movie.
Venti's 20.
Yeah, venti means 20.
Yeah.
In Italian. It's grande.
Yeah,
and grande.
grande.
Grande. There's a large and a grande. Okay, they both mean the same thing.
Yeah. And Paul Rudd, he's great.
Yeah. I don't
Anyway,
like
the
that
reason
much.
I brought up that Pike Place specifically when you were talking about that is I saw a video that if you get it from like Costco, you have to check the bag because it's actually manufactured by Nestle, and they just have the trademark for the label.
Really?
Yeah.
So it's not really Starbucks.
It's just basic Nestle coffee, and they take the logo and make the bag.
Yeah. I will say this:
Which I thought was crazy.
I'm not a fan of Starbucks, but it used to taste much worse. One time it tasted like it went through an ashtray, and I like bold coffee, but they just tasted burned. And I guess now they've changed it. I've had it. It's not my favorite, but I've had it.
I like their espresso better than Dunkin', which is why I typically choose Starbucks if I'm going to go anywhere. I don't like just regular coffee. I only do espresso. But most of the time, I'm drinking energy drinks. And you guys make fun of me for it. But
By the way, I was just in a meeting with Howard Weiss from ESCO, and he told me there's a caffeine gum that you can get. It's called Rev. I go, what? I've never heard of it. So, because sometimes, you don't want to walk around with a cup of coffee, but I'm not going to find some of this stuff.
Yeah, I got some in Dallas last time.
yeah.
Rev gum.
He said his doctor recommended it to him.
Yeah.
My doctor's telling me stop with the caffeine. So why?
Steve's all about gum and sunflower seeds lately. You've
Yes.
been all about those sunflower
Yeah,
seeds.
I bought like a 26-pound bag of sunflower seeds on my desk right now.
It's bird food, literally.
Tastes good. I like them.
Yeah, it keeps me occupied with
I don't have the patience to sit there and break them all apart. You just throw a handful in your
I'm like a
mouth and chew it up
bird.
and
I have it
spit
down to
out.
a science. Just
Yeah.
I can't.
See, what I used to do is I used to put a handful of them in my mouth, and they'd all sit in my cheek, and then I'd do one at a time, move it over, and then spit the shell. Move it over, bite it open, spit the shell. But like after a day of doing that, because I had the same thing, I was like addicted to sunflower seeds for a while, and the top part of my mouth would get so raw from the salt, and the
Yeah.
seeds always just sitting in there. So you gotta be careful.
like a chipmunk.
Yeah. Yeah.
All right, I think we've talked enough about
Oh yeah.
that.
Absolutely.
So we'll see you on the next one.
See you on the next one.